Source code carries patterns that go beyond text. Indentation, line length, identifier density, and structure rhythm form distinctive visual signatures that even reveal which programming language, project, or developer produced the file. We present Source Code Minimaps, a research toolset that turns source files in 128 by 128 grayscale images, minimaps, and uses convolutional neural networks to classify them along multiple dimensions, such as programming language, original project, and author. The toolset is composed of three integrated components: a Python inference backend, IntelliJ IDEA plugin, and a VS Code extension. Together, they bring deep learning-based code analysis directly into developers' workflow. The backend is implemented in Python using Fast API, chosen for its native asynchronous I/O support, essential when receiving image uploads under load, and for its automatic Open API documentation as well. At startup, the API loads a pre-trained classification model in ONNX format through the ONNX runtime. ONNX was selected over native PyTorch because it's a framework agnostic, lightweight, and significantly reduced deployment size, fitting easily into a Docker image deploy on a single Amazon EC2 instance. The main endpoint accepts a JSON payload containing three fields: the project name, an MD5 hash identifying the source file, and PNG minimap encoded in base 64. The response follows a structured vectors of vectors schema containing project, language type, author, and returns the top-end candidates classes with confidence scores. The contract right now is fixed, so it allows feature models to plug in without breaking client's integration.
The VS Code extension, reading TypeScript, follows the same conceptual pipeline, but adopts a different presentation strategy aligned with VS Code's UX conventions. Activation is performed through the comment pilot, invoking the comment source code minimaps analyze current file. The extension reads the active document, generates the minimap using the PNG.js library, computes its hash, and dispatches the request to the backend. Instead of a simple notification, the result is presented in a dedicated WebView panel, opened side by side with the source code. The panel displays the project, file path, hashes, and a structured grid of predictions cards, one per target, each showing classes ranked by confidence with horizontal bars. This rich visualization is intended for deeper analysis sessions, where developers and researchers can review predictions in detail and compare results across files.
The IntelliJ plugin, written in Java using the official IntelliJ platform SDK, integrates seamlessly into the IDE's user interface. Represented by a save style icon in the main toolbar, captures up to 128 lines of the active editor. The plugin renders the source code as a grayscale image. Each character becomes a pixel whose intensity reflects its category: white space, digits, uppercase letters, lowercase letters, and symbols. The image encoded in base 64 and the project name, hashed with MD5, are sent asynchronously to the backend by a background task, ensuring the UI remains responsive. When the response arrives, it comes with project name, type, and author. This makes the tool suitable for a routine inspection in a day-to-day development. Source Code Minimaps demonstrates that visual representations of source code can be combined with deep learning to produce useful insights inside every developer's IDE. By providing two plugins with a unified backend, the toolset supports both research workflows for studying minimap-based classification and practical adoption across the two of the most widely used development environments. The full source code, datasets, and models are all available in our public repository. Thanks for watching.